In this video, I will try to help you out with exercise R3 of the refresh of chapter 9. Now, in this exercise, we get two tables, and they ask us first to show that both of these tables correspond to a linear formula. You can read example 2 to see how to do that. I will move on to exercise B, where we have to make a linear formula for each of these tables. Now, as you know, for a linear formula, we need a gradient and a y-intercept. So that's what we need to look for. Let's look at the first table first, table A. The general form of a linear formula looks like this: y equals ax plus b, where a is the gradient and b is the y-intercept. The gradient tells us how much the graph goes up or down per one step to the right. So let's look for the gradient in the first table. We see here that we have an increase of 6. But that's not per one step to the right, that's per 2 steps to the right. So that means that the gradient isn't 6, but it's 2. So y equals 2x plus b, halfway there. B is the y-intercept. That means the place where the graph intersects the vertical axis. Now at the vertical axis, the x value is always 0. So all we have to do to find the y-intercept is look for 0 in the table for x and read off what the corresponding y value is. So in this case that would be 3. That means that the y-intercept is 3. And that is the formula that corresponds to table A. Table B then begins the same way. We have a linear formula, so we write down the general form first, y equals ax plus b, and we're going to look for the gradient and the y-intercept. Now again, we have steps of 6 in the bottom row with each step to the right, and in this case each step to the right is in fact a step of 1 to the right. So here our gradient is the number 6. For the y-intercept we have to do a little bit of work. For each step that we take to the right, 6 gets added, and we need to find the value for y below x equals 0. We cannot find that right now in the table because the table starts at 5 and not at 0. So what we have to do is to extend the table a little bit. 0, 1, 2, 3, 4. These are the values that are missing. The next one is 5, which has a 3, and 6 with 9. So plus 6 for each step to the right, that means minus 6 for each step to the left. So just keep taking steps of minus 6 to the left each time. So minus 9 over here, minus 15 over there, minus 21 over there, and minus 27 over here. So this is the y-intercept we are looking for. So y equals 6x minus 27 is the formula. Now in exercise C, we don't have to look at these tables anymore. They give us 2 points, 0 and minus 4, and 3 and 11. And we have to make the formula for the line that passes through these 2 points. Now this is going to be a straight line, so again, we start with y equals ax plus b, and we have to find the gradient and the y-intercept. Let's start with the y-intercept this time, because that's easy. Look at the first point. It's at 0 and minus 4. This point is on the y-axis because the x-coordinate is 0. That means that minus 4 is the y-intercept that we're looking for. So all we have to do is write down minus 4 for b. Halfway there, we're still looking for the gradient. We can find that by using the other point. Of this point, 3 is the x-coordinate and 11 is the y-coordinate. If I replace both x and y with the corresponding values, I can calculate a. So instead of writing down y equals, I write down 11 equals, and instead of writing down a times x, I write down a times 3 minus 4. And now I can figure out what value a should be. Let's write it down a little bit shorter first. What number should be here? What number minus 4 is equal to 11? that should be 15. 15 minus 4 is equal to 11, so 3a has to be 15. If 3a is 15, then a is 5, and there's the gradient we were looking for. So final answer here, formula 5x minus 4.